So, welcome to Austin PHP in the weird Wednesday night meetup rather than the Thursday one, March 2015. I'm Ian Lippman and I'm going to talk to you about HHVM. Now notice I didn't say HHVM and hack because the hack part of this presentation is going to be relatively condensed relative to maybe some of your other presentations that you've seen on this topic. I'm going to talk about specifically implementation details of how to get your code running in this runtime. So, a little bit on who I am. I was a contract web dev until late last year, and one of my contract clients begged me, pleaded, and I went full-time with them. I am responsible for their API and some stuff in front of that, depending on the phase of the moon. Now that we are actually getting a front-end team, hopefully I'll be back to having an output format of JSON rather than HTML, because JSON actually works cross-browser mostly. In this particular position, we don't have HHVM in production. I'll go into why that is a little bit later. However, on one of the other contract projects that I work on, we actually do have HHVM in production running standard PHP code rather than hack, and it works great. Again, there are a few gotchas on HHVM that I'll cover, but I actually have real world, this stuff actually works in production. Of course, you probably already knew that because, you know, Facebook, Wikipedia, Baidu, Etsy, and a big list of others are using this runtime. But sample size of one, it does work. And if you want to follow me on Twitter, look at GitHub. I played around, and there's actually a PHP library for calculating dates based on weird counting schedule of holidays and business days on there. Code quality is great, 100% test coverage, if you need that sort of thing. So, here's what we're going to talk about. Relatively big list of stuff, but it goes by quickly. So, we have the HHVM engine, the runtime itself, which by the way is at version 3.6 right now. 3.7 is in dev. It'll come out in about 6 weeks or so. 3.3 is the current long-term support version. Long-term support meaning, maybe 6 months or so. It's not like Ubuntu where it'll just go on forever. CentOS, which will go on forever and a day. This is a fast-moving runtime. That's a good thing, but keep in mind that it's going to be shorter release cycles. So we'll go into what makes HHVM tick, why it ends up executing your code faster than your standard PHP runtime and maybe even PHP 7. We'll also, a little later in the presentation, go into how to get it set up on your machine. Spoiler alert, you're going to be running Linux for this. The Mac version does not support just-in-time compilation. The Windows version does not exist. VMs are great. We'll also go into a performance comparison, including a benchmark at load. Thanks to Blitz.io for charging my credit card for that, but whatever. And a couple of configuration gotchas about running HHVM and then running it at high performance. There are a few things that I've run into that are not immediately obvious how to keep the thing from erroring and failing to start. I'll go over these there so you can actually get it running. And there are a couple of compatibility issues of things just flat out not being implemented in HHVM. Note that while most of your testing, or most of your frameworks that have unit tests, they pass with flying colors with 80% code coverage and 100% test passing, and Facebook and the HHVM team are working for parity with the main runtime. There are certain things where they're just not prioritizing it. If there's a loud enough cry for a certain compatibility fix, or it's an easy fix, they will actually make that fix, and I've seen that happen, for example, about a month or so ago when they had they fixed an edge case around session handling that was failing a test in one of the Aura PHP libraries. But do note that the runtime as it stands is not going to be 100% line-for-line PHP compatible. Additionally, we will talk about the hack language. You know, one of the most easy to Google things right behind Go. But if you search for hackling, Facebook's documentation is decent. Not quite as good as mainline PHP, but it's pretty good. And it adds a lot of quality of life fixes and changes around the PHP language that allow for better programmer productivity, as well as this lovely concept called asynchronous programming that doesn't end up in the callback pyramid of doom. We will also talk about whether there is a performance impact of using hack, at least outside of async. Spoiler alert, there isn't. We'll get into that later. At least there isn't right now. I'll also talk about how over the course of this afternoon I did some changes to a small application to move it from just standard PHP over to hack and kind of what that looks like. And I believe that is it. So, this is one of the only big walls of sentence text presentation slides that I've got here. Bear with me. The HHVM engine its magic sauce is just-in-time compilation and relying on the fact that your code during runtime doesn't change as much as you think it does. So it can infer types for your variables. It can then place guards around function indications with those variables and saying, okay, if you're having an add method, for example, and you're passing in A and B, well, it looks like after running through your code 11 or 12 times, oh, he's just adding integers together. All right, let's build a custom version of this function at runtime that only takes integers, checks if they're integers at the beginning, checks at and then goes ahead and has highly optimized machine code rather than some interpreter stuff way up the performance continuum to add those numbers or do whatever you need with them. With the option to bail out if, oh my gosh, I'm actually adding a float to an integer now, what the heck do I do? So with that, let's get into what actually happens in the engine. To start with, you'll usually go through a few profiling runs. The default is 11. You can change that with a configuration setting shown right here. This is all in the Ubuntu version where you're not compiling the thing from scratch. It is in etc HHVM server.ini. Same format as php.ini, just with a few extra configuration variables. So you run over your code a few passes. That allows the profiler to figure out what types of variables you're throwing into your functions, what types you're getting out, if you don't have a function signature saying that, for example, you're passing in integers all the time. With that information, the runtime can figure out, okay, this is most likely going to be an integer and an integer, an integer and a float, an integer and a string as my function arguments, and then build an optimized bytecode path around that through a multi-step process that includes optimizing out things like you having a block of code that says if false. Well, it's just going to throw that away. Now you'll notice this thing called Repo authoritative mode that we actually do not mention quite yet. But jumping back just a little bit, once we have an idea of what to optimize, the just-in-time compiler then goes ahead and builds a execution path based on okay, I know this is an integer, I know this is an integer, I know this is a float. Let's go ahead and build the machine code to do exactly that through a couple of steps. You go from this hip-hop bytecode, which is very similar to your PHP opcodes in the mains and runtime, then to the hip-hop intermediate representation, which is, again, you end up with a couple of different intermediate representations, architecture independent assembly language, and then finally your lovely x86 assembly language that goes fast and breaks things. And at any point in the process where the code is such, your arguments are, oh, I'm being passed a string rather than an integer, or I'm being passed a float rather than an integer, the runtime can say, oh, wait a minute, I don't have an optimized function for this. I'm going to bail out into interpreter mode, and if I need to compile an optimized function later. So it is, this all happens behind the scenes in a rather advanced process. You can actually look at the C++ source code for this thing and figure out exactly what makes it tick. But the point of things being is you're not going to get your optimal performance on the first, second, third, fourth, or fifth runs unless you configure things differently. But after you run it a bit, after you warm up the just-in-time compiler, then you'll start seeing very significant performance gains, particularly on CPU-bound code. So, this is the part about repo authoritative mode. And if you are familiar with PHP 5.5 plus, you have something called opcache. This is sort of like opcache, but really not. What repo authoritative mode does is it takes a bit more time versus your standard runtime compilation and interpreting steps, and analyzes your code, does dead code detection, etc., to figure out what's the absolute fastest way I can run this code given what I know prior to runtime. It's static analysis or a fraction thereof. That then generates more optimized bytecode, which is then stored in a SQLite database, which gets dumped onto your hard disk. Difference between that and opcache is ephemeral. As soon as you restart your runtime, it goes away. This stays. You can restart HHVM as many times as you want. That SQLite database will stay there until you delete it, and that will speed up the execution of your program. Now the catch here is when you turn on repo authoritative mode, that SQLite database is all the code you're running. So you have to compile in all your code, all your vendor code, etc., which doesn't take too terribly long, but you have to keep that in mind of, okay, I'm changing these files, I restarted HHVM, why isn't my new code showing? Well, you put it in repo authoritative mode, it's just reading from that one file and nothing else exists to it. That means it goes very fast. You just have to keep in mind that that is more or less a production-only setting. You don't want to do that when you're doing active dev, because then you lose some of the benefits of writing in PHP, like, oh, I saved this file, look, I refreshed, and those changes are now live. But there are the steps that we go through to get code to that HHVC step from the previous slide are more or less the same, whether you're doing it, all the parsing at runtime, or whether you're doing it at the command line saying HHVM dash HHVC or dash HPHP type HHVC input, output, etc. The difference is where the code ends up, whether that's in memory or whether it's on disk, and how many optimizations you can make on it, because you have inordinate amount of time to compile the thing versus as fast as you possibly can, because you've got a page to render.
Question for you.
Yes. Go ahead.
Sorry, I'm not sure if we're doing, can we do questions in the middle?
Absolutely.
Okay, sorry, I'm sorry.
No, you're fine.
I had two.
Okay.
One being, is there a way to integrate into your production deployment process a flush of that cache?
Yeah, RM, whatever,
so that's it, huh?
HHVC. It is just,
It feels dirty.
it is, the file that you're looking at here is a single file.
Yeah.
And
But is it stored like with the HHVM binary, or is it stored near your
it can be stored wherever you, so see if I have, I don't think it's actually have the configuration setting. A little later in the presentation. It is configurable where it lives.
Okay.
The default, well, on the compilation step, so you do your HHVM-HPHP type HHVC, and then you give a list of input files to compile, and you give it an output directory, and then it'll drop your HHVM.HHVC database file wherever you want it. And then you configure your runtime. Okay, pick it up from here.
Gotcha.
Again, all of the nice tricks about HHVM do work outside repo authoritative mode. It will still work much faster than your standard PHP 5 installation. This is just an extra burst of nitrous on your server, so to speak. One note here, I mentioned create function prior to this presentation. Create underscore function, which is found, for example, in the Twilio PHP library, because it's 5.2 compatible, and 5.2 compatible doesn't allow you to do closures. That, as well as eval, do not exist in repo authoritative mode because you can't statically analyze that. So you will actually get a 500 at runtime if it sees that code in your file that is not called at compile time, saying create function is not supported in repo authoritative mode, fix it. Use a closure. It took me maybe 10 minutes to fix the 2 instances in Twilio's resource.php class that used create function, and it took 10 minutes because I was using Nano rather than PHP Storm. So it's not a big deal. It's just something you need to be aware of. For the most part, your repo authoritative mode and your standard HHVM execution are very similar. Your other question?
My other question, I'm having trouble finding the answer to this, so I don't know. I mean, if you've played with it, you might know. It doesn't strike me that it uses the dot block annotations at all for its hinting. Like you can specify.
No, it doesn't.
Oh, okay, like you can specify that something should be an hint in the dot block.
Yeah, it does not use.
It's not using comments at all for that.
No.
Okay.
Your at param or at return.
Yeah.
Those are not used. However, we will in the hack language portion of this presentation.
Yeah.
It supports full parameter and return type ending, including scalars.
Right.
So that's where you would do it. You don't do this little hacky comment thing.
Okay.
Neither does PHP 5. So.
Well, sure. Yeah, not natively.
Yep. Okay.
I've got a question on that
Go
side
ahead.
too. If you don't mind, yeah. So I'm just curious, like, assembly code is like very architecture dependent. So I'm wondering what the purpose of the step is going, like, I guess VASM is what, virtual?
So what that is instead of actually assigning physical register values for your various instructions, and instead of having the specific instructions for, say, x86 or ARM or PowerPC or any of those architectures, you have a step above that the code gets to that abstracts all that platform-specific assembly language stuff while still being relatively close to the metal. In that way, your compilation steps, your just-in-time runtime steps, can get up to that point and not be depending on any one architecture. They're actually working on getting ARM support right now. x86 64 is the only thing they've got.
That's an abstraction on top of exactly what platform they support.
Uh,
For now.
Yeah, for now. Again, ARM support appears to be coming pretty soon, and they're actually integrating LLVM again soon, so that moving to other platforms such as the Power8 or whatever it is going to be easier. But that's going from VASM to architecture-specific assembly language is the idea there is so that when they move to that new platform, whatever that is, they don't have to change the entire stack.
Okay.
It's a bit more modularized than at least some runtimes out there.
Plus, it's a problem they don't have to solve.
Yep.
Converting VASM to platform specific is a problem that's well documented elsewhere.
Like, is there a definition? Like VASM, since there's no inherent like architecture there, is there like a VASM that they chose? 'Cause, I mean, you could implement that a bunch of different ways, right?
Honestly, I am not sure on that particular point.
Okay.
The thing with HHVM is all of the sources now it may be a little bit behind what Facebook is using internally, but all of the source for the HHVM that you can download and use yourself is available on GitHub, Facebook, HHVM.
Cool.
And the pieces like the lecture, the parser, the bytecode compiler, the HHIR compiler, the VASM step, and then converting to actual machine-specific assembly language, that is all there.
Okay.
It's all written primarily in C++.
Great. Thanks.
So, again, to get into Repo authoritative mode, here's your magic command line. This puts it into the bytecode compiler mode. This tells it output me that SQLite database. This is where you output it to. For example, var run HHVM. And then the way they recommend that you work with this is you give it a list of input files, and then it'll iterate through those, analyze, and then do the compilation step. There are a few settings that you'll need to change to turn on the rocket fuel mode. Repo authoritative true, and then you'll want to point the path to this. Now, an issue I ran into today, and I wasn't able to get Repo authoritative mode to work until I did this, was if you compile your code with respect to a certain directory, those paths, the absolute paths, will be hard-coded into that SQLite database. So you will need to add this setting. In my case, it was because of lazy user share Nginx HTML. Once you add this, then your directory resolution within that database works, and your code will actually run rather than erroring out pretty quickly. And this is about 20% speed improvement over just your normal HHVM speed up, which is already, depending on your code, factor of 2 or 3. So there are some configuration pieces that are not terribly well documented on HHVM, and if you're running this in a more dev-ish environment, you may not have 16 cores on a PV Open Compute server to serve your page requests, in which case this number is going to be way too low, and you're going to load test your application, and it's going to time out, and you're going to wonder why. It's because your application or some piece of the runtime is at least somewhat I/O bound, and your CPU is sitting there wondering what to do. Also, you could be running an older version of HHVM. Unfortunately, it's not. Their performance is consistent on the LTS releases. They were having some performance issues with, I believe, 3.5, just depending on what you're working on. But you can set this setting right here to say 5 rather than, in the case of my test environment today, 2. And all of a sudden things will work better because the runtime, which is single process multi-threaded rather than the standard PHP, FPM, or mod PHP multi-process, it will actually do more things at once. And then there are a few nuances around error handling. This is a divergence from your standard Zen runtime. It will actually throw a bad method call exception where normally you would get a fatal error. It's nice once you figure out that it's doing that, but you can turn that behavior off if you need consistency with the Zen runtime. This is a little bit more interesting. Default is it's turned off. If you turn it on and catch the error code represented by that, then all of a sudden you can catch every single error, including fatals that you normally wouldn't be able to catch unless you set a shutdown function in PHP. You can now catch those using your error handler, which is actually pretty useful. And welcome to PHP 7. Your function getArgs will no longer return whatever entered the function. It'll return whatever value those variables are at any given point in case you reassign them. Again, PHP 7 exhibits that behavior because it makes things a lot faster and a lot more memory efficient. But if you're used to saying function getArgs halfway through your function call and expecting the thing that entered your function, you're not going to get that. There are a few other things down here that you may or may not use. This right here is the reason that one of the reasons I can't deploy this in production on my day job. We're actually using PDO transported over SSL to one of our databases. HHVM does not support that at all right now. They will at some point, not yet. Another reason that we can't use it in production is we're actually using Falcon, which is a PHP extension. There is an extension compatibility layer. It works somewhat, but realistically, that is a reason why I don't particularly recommend starting a new project on Falcon right now, because HHVM will break your project and PHP 7 will for the time being. Then there's this last thing. I have a library, as Josh noted, because he kept seeing these version updates on it. It's up to 1.4 now because Chrome. And it does business day calculations, including stuff like, okay, is this current date time Easter? HHVM does not have this function that PHP 5 does have, as well as a few other kind of corner case functions like that. You can emulate them in PHP with probably the same speed that they're being executed in C on the extension side. It's not a big deal, but there are certain cases where a function will exist on the PHP side and just flat out won't on HHVM.
I know, that's the thing.
Yep. I learned about it when building that library.
Today I learned that Easter date is a thing.
Yeah.
So,
I just looked that up.
Also Easter days.
yep. So before I jump into benchmarks, any more questions? Just shout them out. All right. So, and I have the fuller benchmark information than this, if anybody wants to see it later on. But this is Repo authoritative mode on what is not the best example of HHVM friendly code. I say that because HHVM likes working on functions and code constrained by those functions, because you don't have this global state to track and wonder, well, do I actually have, can I actually depend on the types of these variables? And the answer to which is, I don't know, maybe. But small app, just hitting the home page, which sets up the various services, renders a template, all that sort of thing. This is code that has not been optimized for HHVM in any way whatsoever. This is Repo authoritative mode. 71 milliseconds, this is about 300 and some odd hits a second on a machine that has 768 megs of RAM, is running MySQL all along with this. One CPU, yes, it's SSD backed, yes, it's a fast CPU, but this is a VM that cost me $5 a month. Now, by way of comparison, this is the best tuned standard Zen engine PHP 566 stuff that I could build. This is, both of these are using Nginx. HHVM is actually running over a TCP socket. FPM is running over a Unix socket, which gives you a little bit more performance advantage there. Opcache, what I was mentioning earlier, I told it assume that nothing on the file system has changed until you restart. So I'm not dealing with any file system calls here. This is basically given the machine that I'm running as fast as it gets. And you'll notice it's lightning fast up until the concurrency increases and then it starts struggling. 100 milliseconds to load a page still isn't bad, but you can see the performance difference between this, which is, as far as I know, as good as you can tune the Zen runtime, and HHVM with all else equal. Now I'm going to show, let's see here, let's pick one of these standard ones. And because we're running with relatively little RAM with other things on there, we actually got a couple of 500s in here due to load. And this is without Repo authoritative mode turned on. So it's still faster in this relatively trivial case, just not by as much. And a lot of that is just file system access calls. So this is after converting portions of the code on Raffle to hack, which I'll go into momentarily. You'll notice there's basically no performance difference. Right now, the information that is collected, type hints, return type hints, not using an array for every single data structure you can think of. All of that doesn't really impact performance at this point. It may later, but at this point it is more about programmer convenience than anything else. The catch to that is the async implementation that I'll go into a little bit later. This is the HHVM portion of the presentation, not the hack one. We're getting to that.
Is your hack benchmark with the Repo authoritative mark still?
Yes, it is.
Okay, okay. So
Yep.
it's not like hack would get you that same performance
No.
without it, no.
No, it's, as far as I can tell, and I've been told multiple times, and people keep asking this question in the HHVM IRC room on Freenode. And by the way, there's usually a couple of people in that room on Freenode most of the time. So if you have questions, you can just ask there. They're really helpful about that. But what they've said is, do not convert your code to hack expecting a performance increase unless you're using the async pieces. Otherwise, it is merely for making sure that you don't write bugs. So, last slide before we delve into hack. Setting this up is actually pretty darn easy, provided you're running Ubuntu. There's a package available. I'm guessing that that package is actually Debian compatible as well. They may even have that on their wiki. The GitHub wiki for HHVM is actually really useful for this sort of thing. You can set your configuration files, everything works pretty much out of the box. Again, you'll use this very similarly to how you use PHP FPM in that it's running as a fast CGI process. You point Nginx to, or Apache actually, to port 9000. You say, forward all my PHP stuff over here, and it does it. They actually had a built-in web server for HHVM earlier on. They took it out because that is not their area of expertise. So if you don't run Ubuntu on your servers, like for example, I'm more or less on our production stuff allowed to run anything as long as it's a Red Hat variant, you will need to compile from source at this point. There's been talk of actually, for example, allowing or building a Amazon Linux package, which Amazon Linux at this point is CentOS 7 based. That hasn't come to pass quite yet. The compilation process is basically you download a bunch of packages, you compile a few things that your OS doesn't have as packages, and then you compile HHVM. And while it takes a little while, it doesn't take too terribly long. Even on like a T2 micro with a couple gigs of RAM, it took about an hour and a half. So I still had CPU credit left over to actually have a useful machine afterwards. One gotcha on here is one of the dependencies, depending on how old the version is that comes with your OS, is Intel Thread building blocks. They have a test routine that's part of the make process. If you run that, then your computer will spin for a while. So you'll want to edit the make file, not retest the thing that plenty of people have tested before, and just build the darn thing, in which case it builds quickly. Again, newer versions of, say, CentOS or Debian won't even need compilation of that particular package, but older versions do. It's just something you need to look out for. The easiest way to get into HHVM at this point, barring, for example, going to Heroku or some other platform as a service that has HHVM built in, is pull down a Ubuntu machine. There's also the excellent Puppet, whatever you want to call it, PUPHPET website, where you can build a VM with, among other things, HHVM installed. So again, it's for 99% of cases, you can swap this out for PHP FPM and things will just work. So here's the part about Hack. The language that is incredibly hard to Google is a nice quality of life improvement over standard PHP and does not have PHP Storm support quite yet, but will soon. You'll see a lot of new features in PHP 7. I'll let Josh get into that at a later meetup. A lot of those, the community that's been programming stuff in Hack they've already had this feature for a while. Examples of features that have already made it into PHP that Hack had before were generators, so your yields keyword, and for things like argument unpacking that showed up in PHP 5.6, HHVM generally supports those very quickly after they become part of the language on the Zen side. But because they don't have to go through the RFC, does do a couple of Zen people like it or not? Does everybody else like it or not? Let's go to a vote, let's pull this in. That process, since they don't have to do that, and since their needs for the language are driven by, well crap, we have this huge code base that's written in PHP or some variant thereof, we need it to do X, Y, or Z thing, let's just build it. And they're able to move a little bit quicker on some programmer quality of life features that are particularly useful in large code bases. So the big thing here, again, performance-wise, is this. We'll talk about that a little bit later, as well as this static analysis piece where you can have a type checker running in the background, and as soon as you save a file, it'll run through the type checker without executing the thing with all the side effects and say, whoa, 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 you've got something at this line, at this character. It's an integer, I was expecting a string, fix it. And it does that with a pretty easily readable syntax. So there are plugins for editors that people use that support hack. For the dev I did today on this, I actually used Sublime. Sublime 3 has a hack plugin. The catch there is you'll need to set it up. If you're not using Linux, you're going to need to set it up for remote type checking, because you're not going to want to set up HHVM under Mac OS at this point. They're working on that, but it's not here yet. GitHub Atom has support in a similar way. Basically, all of these rely on the HH_client to do your type checking, but they do have completion built into them. And then PHP Storm looks like this summer they will be getting hack support. So, a couple of language features on hack. A lot of stuff around actually declaring types in places. For example, you can declare the default type, or the type at all, on various properties within your classes. So you can actually say, this is a Boolean, or this is an integer, or this is a foo or bar, or whichever class you want. In your property declarations, your return types, the PHP 7 return type syntax is a direct port from hack. You can specify scalar types in your type hints, and it will actually, you'll get a 500 if you violate those constraints. Nullable types, so you can actually say, I want this particular parameter or null, and you can go ahead and expand that out to, this can be, bar can be a string or null, and let's give it a default of something other than null, which that cannot be done in PHP right now, at least not in the function signature. There are also some other pieces of syntactic sugar with hack, like having default values either in function executions usually, or in constructors that you can actually feed in an expression rather than just a value, which if you abuse it, it can get messy really quickly, but it's useful in certain cases. And then you've got generics, so you can, for example, the internal classes for arrays use this a lot. You can have a foo of type T, a vector of strings, or a vector of database domain objects.
Is that like the C++ vector?
That is similar to the C++ vector in this case. The generics piece is very much inspired by Java, so your type erasure rules are similar here. which leads into these collection types. Instead of having the array be the end-all, be-all place that you throw data, you can use more structured ways of having a collection of data, whether that's a map of, say, strings to objects, or a pair of an integer and a string, or a vector of strings, which a vector would be your, every language other than PHP, array, where it's numerically indexed and every object within it is the same type. And a set is a collection of objects where they are unordered, and I believe they have a constraint of no more than one instance of a given object shows up in there. So you can't have a set of 9, 9, 9, 9, and 9. Additionally, if the array types weren't enough for representing your data structures, there's a concept of shapes, which allows you to very quickly build a data structure of, say I have a name and it is a string, age, integer, birthday, date, etc., etc., etc. No logic attached, just a structure. Where then you can pour your database results or anything like that into it. You can use a shape. And that ties in again with the HH_client type checker. This is all about making code more predictable so that when you're looking at something, it's a little bit easier to see what's going on. Type aliases are something that I won't get into here, but you can find documentation on any hack-specific feature. Facebook actually has some pretty good documentation on their site. So you've got this annotation syntax. Notice that this is not your doc block annotations. This is something that gets parsed by HHVM on hack code only. One interesting one is memoize, which if you have a function that does a rather complex calculation, like say calculating the value of pi to X number of digits, you can drop that memoize annotation on top of it, and then for any given input value, as it returns, HHVM will cache that. And any time you hit that function with that parameter again, it'll just return the cache value. And you don't have to manage that caching logic yourself. That only should be used if your function is a pure function where it's just taking input and doing some calculations internally and giving an output. If you have some side effects in there, that's not a good thing. But for things that you're probably doing a fair amount anyway in terms of calculations, this is a nice bit of syntactic sugar, so you're not reinventing the wheel every time.
Hey, Ian,
Yes.
where does that cache go at?
I believe it is memory that is local to the HHVM process, which again, since it's a threaded environment, that is going to be basically anything that is executing, anything that's hitting that HHVM process will have access to that cache or memoize.
And it stays forever?
It stays, I believe, until you restart the process. So it's just an in-memory local cache.
Is this useful? Can you implement your own decorators for methods?
I'm not sure.
Oh,
So this last piece here, XHP is, as it says, they're not HHVM specific, but I believe it does come baked in, where you can have your HTML elements as first-class citizens. Starts off with, I believe it's actually XHTML. So
is it like a templating thing?
yes, it is.
Okay.
So you end up with the ability to automatically sanitize using a pretty lightweight syntax, outputs. You can actually declare your own syntax on top of XHP. For example, there is there's kind of an XHP grammar that you can download for Bootstrap. So instead of having this big long, let's see here, a space class equals btn, btn dash primary, btn dash large, etc., etc., etc. XHP will allow you to do that in a much shorter tag. And again, it's a quality of life improvement, but it also has this sanitation piece added to it, which will cut down on cross-site scripting vulnerabilities a bit. So that whole HHVM, well, hack isn't faster than PHP asterisk. This is the asterisk. Being able to do multiple things at once using HHVM's threaded architecture is actually a big performance win in certain cases where you need to make multiple HTTP requests out to other microservices, or you need to hit the database for a couple of unrelated queries. You can manage those operations asynchronously, and databases are live on this as of the latest version of HHVM for MySQL, such that you can do things in parallel in your code without having to write a big old callback pyramid of doom. The keywords that you use for that are async and await. Async is how you declare your functions. Await is what you put right before any statement where it's go ahead and make this call and pass control over to anything else that is similarly asynchronous while I'm waiting for this blocking I/O, or I/O that would normally be blocking, to occur. So again, it's powerful when you have a curl request, a database call, and a couple of cache lookups. Cache lookups take maybe 50 milliseconds because your cache is slow. Your database takes another 50 milliseconds, and your curl requests are taking, say, another 50 milliseconds apiece. There is an async version of curl multi in here, so you can layer that on top of your memcache async and your database async and turn, okay, maybe 150 milliseconds, maybe 200, maybe 250 into all of these things are happening simultaneously, and 50 milliseconds later, they're all done. So that is, versus just running your PHP code on top of HHVM, that's going to be your big performance improvement. And that is also the only thing that, well, I'll get into what I was about to say momentarily. First, let's talk about the type checker. HH_client, which comes bundled with HHVM, is a way to, in near real time, on file save, check your code, say, oh, wait a minute, there is a type error here, or there's a syntax error there, and resolve that as you're editing rather than waiting until runtime and saying, oh my gosh, this thing actually doesn't parse. And that will do, this is actually more strict on, for example, return types than the runtime is. So it is very much a code correctness tool rather than a will my code run tool, which again has positive implications for code readability and trying to deal with that particular class of bugs. I'm not going to say it eradicates an entire class of bugs, because when anybody says that, they're wrong, but it does help. So this is why I gave you a link to the slides, because I don't expect you to read every single line of this. The idea here is the syntax of the type checker's output is relatively human readable. It'll tell you the file, the line, the character on the line, and what it thinks is wrong with your code. So it'll say, well, I saw a vector declared up here, and you're using it as an integer. Pretty sure that's the wrong thing to do. Things like that will be caught on save by HH client, which runs very, very quickly. Because again, they're optimizing this for running on a portion of Facebook's code base and still allowing for engineer productivity on the engineer's local machines.
Is the type checker something you would run on production, or is that something you turn off?
The type checker, there's type checking built into the into HHVM. If you're using hack and you're using type hints everywhere, then it'll do that automatically.
Okay.
But HH client is something that you run on while you're in development,
Okay.
and only while you're in development.
Cool, nice.
And it sets up a server that that you can then connect to, say, sort of like Xdebug, where it'll stream in any errors that it sees in your code. So the cool thing about hack is you can intersperse this with standard plain old PHP. You can move pieces of your code from loosely typed everywhere standard PHP and line by line move it over to hack without giving the runtime any problems. In fact, for the project that I revised today for this, which is the raffle app that Logan gets to decide whether we use mine or we use Josh's
We're
later
definitely using yours today, unless it breaks.
But I modify the main logic file, and yeah, there's only one file, it's like 250 lines, no big deal, to use a lot of the features of hack, while leaving all of my dependencies, so Twilio, OraSQL, and Slim, as is in PHP. That works, and it works perfectly. There are no huge performance implications either way as it stands, so you don't have to worry of, oh my gosh, if I modify one piece of my code to run hack, I have to modify everything. No, you just you change $PHP at the beginning of your file to $HH, and then start moving stuff over. There are also tools for moving in both directions, both from hack to PHP, with the exception of the async stuff, and from PHP to hack. The Hackificator, which is a Facebook project, is the reason that Facebook's huge code base is about 95% hack now rather than PHP. Now, it's not just because of that. The programmer productivity implications meant that people were actually creating new code in hack of their own volition. But the Hackificator, which has a few stages of, okay, I'm looking at this file during runtime, I'm seeing what types flow through here, I have guesses on what those types are. There are a few steps in the hackification process that eventually wind you up with not only code with a $HH at the beginning, but actual types in your function signatures. And that's all automated. So to give you an idea of some of the changes that I've made to turn this stuff into cat, you'll see actually declared property types here. You've got your question mark HHVM here. You've got let's see here. You've got usage of your actually scalar type hints top here, and you'll notice the use of vector a couple places. You'll notice the use of cast to int, because again, this is actually checking types, and if you're pulling from the database, chances are you're pulling that as a string. And also used one of the nice things about these collection classes, which by the way, you can still use, for example, array map or any of your standard array underscore or similar functions on this, and they'll just be treated as an array. But in this case, array underscore map, the syntax is kind of wonky, so I just used vector map. So map on that function, and that gave me what I needed. Syntactically equivalent to the array map call that I had before, just a little cleaner. And with that, that's my presentation. I'm going to go back all the way to, let's see here. So when I mentioned about Repo authoritative, this is kind of what the compilation process looks like. When you tell it, okay, compile all my files and give me that SQLite database, here's the output you're going to see. As you can see, for it skipped all the tests, which is fine. It spit out a 3 or 4 meg file, and it only took 3 seconds for probably a few thousand lines of code, including the libraries. So it's not screaming fast, but considering that it's making optimizations pretty heavily along the way, it's decent. With that,
Well, let's do questions and answers in a separate video. So let's give a round of applause here.